Hello and welcome to this webinar, where we will introduce how the VI grade NVH Simulator solutions accelerate product development. My name is Dave Bogema, and I am the Director of NVH Solutions at VI grade, responsible for NVH simulators and simulation. And I am very happy to be here today talking about NVH solutions. I've spent the last 25 years working in the automotive industry as an NVH engineer, consultant, and technical specialist in automotive sound and vibration. And I have enjoyed the good fortune of working with the NVH Simulator Solutions and NVH Simulator team for over 15 years as a technical expert and product manager. We've got a lot to cover today, so let's get started. Before we look at the NVH Simulator Solutions, let's first take a quick look at what NVH is. NVH is Automotive Sound and Vibration. This includes powertrain sound and vibration, and you can see some of the typical phenomena here: boom, shake, growl, tonal noises from gears and motors, and so forth. It also includes road noise and vibration, from secondary ride to imbalances, and structure-borne and airborne road and tire noise. Wind noise is another major component. And then we have anything and everything else on the vehicle that makes sound or vibrates: brakes, HVAC, chimes and warning sounds, and so forth. All of this falls under NVH. What we will be covering today addresses how we engineer the right sound and vibration characteristics into the vehicle. NVH is one of the main attributes controlling and delivering vehicle refinement and brand DNA. Comfort, quality, and character are all communicated to the driver, passengers, and observers through the sound and vibration of the vehicle. Sound and vibration are intrinsic parts of the driving experience. Consciously or not, people make decisions and form opinions based on the sound and vibration they perceive from the vehicle. Buying decision, perception of quality, reliability, and proper function, and emotional response, whether positive or negative, are all considerably influenced by the sound and vibration of the vehicle. NVH embraces a number of factors essential to delivering the overall driving experience and communicating brand DNA. In the world of NVH, we're facing several challenges. Lightweighting, the focus on reducing vehicle mass, means less mass allocation for sound package, but at the same time, lighter vehicle structures, components, and materials tend to transmit sound and vibration more easily. Customers expect the same level or higher quality of interior sound and vibration at the same time. Electric and hybrid vehicles bring the additional challenge that we know of as draining the swamp. Like this swamp, there's alligators that raise their heads when the swamp is drained. Our alligators are in the form of air conditioning compressors, power steering pumps, the tones of gears and motors which rise up when there is no engine noise to mask them. Electric vehicles also run the risk of loss of audible character. And all need to comply with the minimum noise regulations, all while maintaining the brand DNA. Many types of engineering data and CAE analysis can be adequately expressed, experienced, and understood visually. Decisions can be made by looking at a computer monitor. NVH data is a bit different. We get a lot of great information from testing, analysis, and simulation, but the results are typically in the form of plots and graphs. NVH data cannot be fully expressed, experienced, and understood by plots, graphs, numbers, and visual means. Numbers, plots, graphs are very useful, but do not answer questions like, does it sound good? Is it better than this other car? Or my favorite, what does it sound like? Thus, we created the NVH Driving Simulator to enable the experience of all the various types of sound and vibration data together in an interactive, real-time driving simulator. With the NVH Simulator, you have full control over the vehicle. Drive just as you would drive a real car with accelerator and brake pedal, steering, gear shift. Change sounds back to back on the fly while driving. You can also turn components on or off, or modify component sounds with filters, or adjust their levels, or swap components, all while running the real-time simulation. The NVH simulator came from a desire to experience and therefore to understand fully what the NVH data we had meant to customers in their cars. That meant adding interactivity and context to the traditional sound quality listening experience. Adding interactivity meant creating an NVH virtual prototype vehicle made up from traditional types of NVH data, which could be driven in a simulated environment. The ability to experience NVH data using highly accurate sound and vibration synthesis in a real-time, driver-in-the-loop situation, including the ability to modify parts of it in real time, enables design for the customer in the field of NVH. It is of course interesting for validation purposes to simulate an existing vehicle, but the value of simulation comes when it is applied to data for vehicles which do not exist yet. The NVH simulator is extremely flexible in incorporating data from many CAE tools, test techniques, and taking NVH data from almost anywhere to allow engineers to experience and assess the best representation of the new vehicle at that time. The NVH simulator technology has developed with the benefit of Brüel & Kjær's long legacy of sound and vibration innovation. Let's take a step back for a moment. For all disciplines and attributes, the traditional approach to designing a new vehicle has been to dream it, get an idea, then make it, build a prototype, then try it, drive it, see how it works. A much more efficient approach is to try it before you build it. Eliminate wasted time and cost of building multiple prototype iterations. Simulate and experience the results of the simulation in driving simulators first. Iterate much faster than possible with traditional approaches. This is the faster, easier, and safer approach to developing vehicles. With all this in mind, if we look at the traditional way cars have been developed in the last 40 years, we can clearly state that this process is not tailored for the new challenges. The traditional way of developing cars can become slow, difficult, and expensive, especially if you need to apply late changes on the right side of the V cycle. VI Grade has worked hard in order to change the traditional V cycle into something which is closer to modern needs. We managed to put in contact the simulation world, typically located on the left side of the V cycle, with the testing world, typically on the right side of the V cycle, and have these two worlds working together. This is made possible through the introduction of driving simulators. And this is not limited to just test drivers or engineers. VI-grade simulators enable realistic experience of NVH and other attributes for chief engineers, managers, executives, customer clinics, anyone who needs to experience, understand, and make decisions on vehicle design, content, and performance. This is exactly what we mean when we say that we bridge the gap between testing and simulation. The result of this is a narrower development cycle, hence shorter, in which potential issues are discovered much earlier in the development cycle. So more variants can be tested and more issues can be identified earlier in the development. The result is a V cycle which is narrower, which means less development time, and in which we have a collaborative engineering process where engineers and decision makers work together. The NVH simulator brings together data from multiple sources into a single, unified virtual prototype. This can include vehicle measurements, component rig measurements, CAE data of many different types, and all of these can be combined into a single model. These virtual prototypes can then be used to communicate NVH information to decision makers and those who need to know. They can show stakeholders and colleagues why their input matters. Going back to the development process, let's look at this from a slightly different angle. This is the old traditional vehicle development process. Particularly with NVH, no representative prototypes are available until very late, well after hard tooling cutoff. So any changes made are adding cost and weight to the vehicle to fix NVH problems. Today that's not really an option. Instead, let's move the point where you can listen to the NVH prototypes and design back to the very start of the development program, even before setting targets. Set objective targets, but evaluate them and get agreement that the targets are correct. As you move forward through the development process, you can update the virtual prototype at any point with the latest designs, CAE data, and so forth, and evaluate it instantly. You don't have to wait weeks or months to make prototype parts and hardware. The NVH Simulator is used by many automakers to deliver better NVH faster. There are 50 VI-grade NVH simulators worldwide, with 20 separate OEMs owning at least one desktop simulator. And here are a couple of quotes from customers. The NVH Simulator technology can be applied in several ways. Let's look at these in more detail. The NVH Simulator software is at the core of all the solutions. The desktop NVH Simulator is the basic workstation. This is where all the models are compiled, and the desktop version provides sufficient context for many types of evaluations. The virtual vehicle model can be driven interactively with pedals, gear shift, and so forth. The models are fully interactive with complete control over the sound. Switch instantly back to back. Turn on and off component parts of the sound like wind noise, road noise, and powertrain noise. Modify parts of the sound in real time with multiple types of filtering and sound modification tools. The static NVH simulator adds calibrated, multi-axial, independent vibration at all driver touchpoints. Built into the shell of a complete vehicle with expansive visuals, it provides the evaluator with the full context of being in a real car. Vibration is inextricably connected to the perception of sound in the vehicle, and vice versa, especially below 100 Hz. And to accurately assess sound and vibration at lower frequency, it is vital that the correct levels of vibration are delivered to all driver touchpoints independently. When assessing conditions like road impacts, idle, lugging boom, and other such phenomena, vibration and sound need to be present together for the correct assessment to be made. The on-road simulator and Vsound enable the playback and experience of vehicle models made with a desktop NVH simulator in a real car interactively while driving, with sound synchronized with and generated in real time based on real-time vehicle parameters of engine speed, road speed, pedal position, and so forth. This provides the most immersive environment for evaluating sounds. Everything that can be done for the interior sound can also be applied to exterior sound. The exterior sound simulator enables the experience of the exterior sound of the vehicle under various operating conditions in the presence of different types of ambient noise and different levels of traffic from the viewpoint of a stationary or moving observer. How do you really know what the perception, preference, or acceptance of your NVH design will be? Gather the subjective preference of customers and stakeholders using jury data presentation and evaluation software. Present vehicle sounds and alternatives to evaluators with several methods for jury evaluation. Collect these results and process them to reveal insights into preference. This can be applied for a single evaluator driving the simulator or multiple evaluators simultaneously experiencing the same sounds and using the free iOS app to report and record votes. Using the same technology as the other NVH simulator tools, Vsound is used to generate accurate vehicle sound on any driving simulator, including all the nuances of sound that give a vehicle its distinctive character and provide auditory feedback to the driver. With Vsound, the simulator will sound exactly like the car, the specific car being driven, not just like a car. Sound design is all about getting the right sound for a specific vehicle, often utilizing electronic sound enhancement or active sound design technologies. With the NVH Simulator, you can try out various sound design concepts and proposals in the context of all other vehicle sounds in a dynamic, interactive environment right on your desktop. Third-party sound design tools can be used together with the NVH Simulator. QNX LiveAMP active sound design software is now integrated into the NVH Simulator. Use this advanced, full-featured active sound design software to design sounds both inside and outside the vehicle. In the past, typically a sound designer would design a great sound in the studio. This would be implemented on a vehicle and evaluated, and the sound would be perceived differently in the car because of the various powertrain, road, and wind sounds, and because of the dynamic driving character of the vehicle. So, the sound designer would go back to the studio, try something else, put it in a real car, evaluate it, and so on. This was not an efficient process, relying on in-vehicle testing and evaluation completely separated from the design of the sound. With the NVH Simulator and the integrated sound design software, sounds can be designed, evaluated, modified, and tuned in the right context of all other vehicle sounds with live driver input in real time in a desktop simulator. The QNX software also makes deployment to production very easy, eliminating months of optimization work to fit a sound to a specific hardware device. Yet another application of the NVH Simulator technology is fleet reduction. Often, large fleets of vehicles are maintained at factory sites and development centers to preserve particular characteristics, problems, error states, or golden vehicles. These are costly to maintain, require space, and they are not truly static. They will degrade or change over time. A better way to approach this is to capture the NVH characteristics of these vehicles and create virtual vehicle models of each. This enables anyone to re-experience these at any time in an NVH simulator. These virtual vehicles can easily be shared between development centers and factory sites around the world. There is no degradation over time and no need to maintain a fleet of vehicles to preserve these characteristics. One of the questions I'm asked a lot is, how much data do I need to make an NVH simulator model? Well, it all depends on what the model will be used for, how much accuracy, and how much detail is required. Simple level 1 models are very useful for benchmarking and high-level target setting and require very little time and data to create. In fact, you can create a simple level 1 model that is completely functional for driver-in-the-loop interactive simulation from a single recording. Models can also be more complex, moving to a level 2 model where the sounds are broken into specific sources, especially for separating structure-borne road noise, airborne road noise, and wind noise. And moving to a further level of complexity, level 3 models accommodate the need to predict and understand what impact specific components will have on the overall vehicle sound. Source path contribution modeling is used to build up vehicle models from the component source level sound or vibration through the sound and vibration paths to the resultant contributions at the receiver locations. And models can exist anywhere in between, matching complexity and capability to the needs of the model. And again, any of this data can be real data measured on a test track, measured on test rigs, or come from many different types of CA methods. While NVH simulator models can be created entirely from measured data or entirely from CA data, the vast majority of NVH simulator models and virtual prototypes are hybrid models, a combination of CAE data and measured test data. Often, test data will be used to provide context for components outside the scope of the immediate evaluation task, or for data and frequency ranges that are outside the scope of immediate evaluation and analysis. For example, say road noise is being analyzed. A detailed, finite element model of the vehicle and a high-quality tire model are used to generate road noise levels for the vehicle, but only up to about 200 Hz. This data can be accurately generated and played back in the NVH simulator, but listening to sound data up to 200 Hz with nothing else above that is not so realistic. A good solution is to use surrogate road and wind data from a similar vehicle, perhaps even modified slightly to match future vehicle intent, and apply this above 200 Hz, while using the detailed analysis results below 200 Hz. In this example, we first hear only the CAE-generated data from 20 to 200 Hz. It doesn't sound very realistic on its own. Next, we add the surrogate data, filtered to include only data above 200 Hz. In this way, the sound can be represented as complete, realistic road noise with the expected full band sound, which provides the proper context to evaluate the CAE data. This is a very basic example of hybrid modeling. There are many, many variations and ways this can be applied. CAE results and data are vital components of NVH virtual prototypes. In fact, the NVH simulator is capable of easily accepting data from many different sources and in many different formats. Time data, frequency spectra, frequency response functions, and other data are easily utilized in the NVH simulator. The NVH simulator accepts measurement data from a wide variety of sources in all common file formats. Some data can be directly used in the simulator with no further need of data processing. But other data needs some preparation to be used in a real-time simulation. For example, test-based time data typically needs to be decomposed into its component parts. During runtime, the data is then not simply played back, but it is actually resynthesized in real time in response to driver inputs. This measurement data is decomposed using incredibly precise and fast time-domain order extraction techniques to separate orders from masking. Data can be further processed to separate the masking noise into its component parts. When needed, the best-in-class time-domain source path contribution software can be employed to calculate acoustic source strengths and mount forces and prepare complex source path contribution or transfer path analysis data for efficient modeling and playback in the NVH simulator. Experience over the 20+ years of development and use in thousands of model builds have resulted in a set of tools which can handle virtually any data set and measurement situation when building NVH simulator models. There are various ways to interact with the NVH simulator models. The engineering interface, or mixer, provides complete control over the NVH simulator models or virtual prototype. Turn sounds on and off, apply many types of modifications and filters, compare sounds back to back, visualize the sounds in real time together with listening. When applying filters, unlike in a sound quality program where filters are applied to the entire sound, here filters are applied to specific portions of the sound. So, applying a notch filter to remove tire cavity noise from the rear tires, for example, is only applied to the rear tires, not to the engine noise or other road noise contributions or wind noise. It is analogous to making an engineering change with a physical vehicle, like changing the tires. It should be noted that the model size and the number of filters and modifications are essentially unlimited. Huge numbers of filters and extremely complex models are easily accommodated. Electric and hybrid vehicles are completely supported in the NVH simulator. One part of supporting EVs is the ability to create models from measured data on a test track or test rigs. This is especially important in evaluating competitive vehicles or benchmarking. It is necessary to extract not only the motor harmonics, but all the harmonics of the power electronics or inverters. Of course, the accurate replay of these harmonics is required as well. Often there are multiple motors as well as an engine in the vehicle, so we provide multiple independent rotating sources. Hybrid vehicle performance can be especially challenging, with a vehicle deciding when the engine should be on or should turn off, the balance of power between engine and motors, and so forth. By supporting external real-time performance models, automakers can use their existing vehicle performance models together with the NVH simulator. And of course, we need to interface to a number of CAE software solutions to be able to generate virtual prototypes of EV and hybrid vehicles long before hardware exists. We have talked a lot about modeling and the sound and vibration of the vehicle, but what about performance? Performance is another aspect of the vehicle that is very important in NVH simulation and can significantly affect how someone perceives the sound, vibration, and sound quality of the vehicle. There are multiple approaches to modeling vehicle performance. Vehicle performance models can be created from on-road measurements, building an empirical model based on how a measured car actually performs. The NVH simulator performance data preparation software typically uses the same data measured for building an NVH simulator sound and vibration model from experimental data, so no additional measurements are required when benchmarking a vehicle or building a model from on-road test data. There are various ways to build physics-based performance models. Within the NVH simulator, there is a basic physics-based performance model calculator which creates a performance model from basic vehicle parameters. For a more complex vehicle model, other software can be used. VI-Car Realtime can be used to generate NVH simulator performance models for use directly in the NVH simulator, from very complex vehicle performance models built in VI-Car Realtime. Real-time performance models like those of Simulink, VI-Car Realtime, and other real-time detailed performance models can be run in parallel with the NVH simulator through various protocols. This is especially useful for complex powertrain logic, hybrid electric vehicles, complex proprietary shift strategies, and so forth. Let's take another step back and see how NVH simulator solutions fit into the bigger picture of vehicle development. VI-Grade delivers software and simulators for vehicle dynamics, ride and handling, motorsport, HMI, ADAS and autonomous vehicles, and of course, NVH. This covers a set of attributes which need to be well balanced in the final vehicle design and production, and it is therefore extremely powerful to have these solutions available from the same provider. The VI-Grade multidisciplinary approach provides the ability for our driving simulators and simulation solutions to simulate many automotive attributes together. Virtual vehicle sign-offs become a reality with VI-Grade driving simulators. Today, you don't have to restrict a simulator to a single task or application. Multiple aspects or disciplines can be combined together in simulators. For example, full motion simulators can include accurate vehicle sound, HMI, and ADAS and AV components. Various disciplines and aspects can be combined and simulated together to provide a more holistic driving experience and assessment. VI-Grade provides an open environment with many third-party software interfaces. Every component of the driving simulator can be utilized without modifying the existing development process. This enables the use of multiple different software solutions for graphics, biotelemetry, sensors, vehicle modeling, tire modeling, and other aspects of simulation across the entire range of VI-Grade simulators. We've already looked at how the NVH simulator can accept data from many different CAE and test sources, but this extends to real-time as well. As with other VI-Grade solutions, the NVH simulator solutions have been designed from the beginning to be open and capable of interfacing to a wide variety of other software. External performance models from Simulink or other external real-time performance models, active sound design software, and other real-time software can be utilized in the loop side by side with the NVH simulator to achieve the high-fidelity NVH virtual prototype experience you need, leveraging existing solutions you are already using. There are numerous protocols and methods supported for integrating the NVH simulator software together with other real-time software solutions. Similarly, hardware can be incorporated into the real-time simulation with the NVH simulator solutions. The NVH simulator software can interface with a wide variety of hardware through multiple methods. And now, I'd like to introduce the VI-Grade Sim Centers. VI-Grade is establishing sim centers for the purpose of education, training, exploratory use cases, engineering services, and support. These sim centers typically have multiple driving simulators, along with conference rooms and facilities for training. Our sim center in Udine, Italy, has a full motion driving simulator, a static simulator, which is a full cockpit and large wraparound visual screen, a compact simulator, and a desktop simulator including NVH capability. Our new Sim Center Detroit has a full motion driving simulator as well as a compact simulator and NVH desktop simulator. Sim Center Tokyo has a desktop simulator including a desktop NVH simulator and a compact simulator. Our latest addition is the Sim Center Millbrook. Located at the Millbrook Proving Grounds in the United Kingdom, the VI Grade SimCenter Millbrook contains a brand new static NVH simulator or full vehicle simulator based on a Bentley Continental GT full vehicle. Calibrated vibration is delivered to all driver touchpoints through 7 independent degrees of freedom. Vibration at the steering wheel, seat, and floor pan, together with highly accurate sound, deliver a completely immersive sound and vibration evaluation experience. And that brings us to the end of the presentation. In summary, VI Grade accelerates the development process across many vehicle attributes by bridging the gap between testing and simulation. The NVH Simulator technology, as the latest addition to the VI Grade solutions, enables vastly improved development efficiency through the use of NVH virtual prototypes. Drive, experience, understand, and decide. VI Grade provides the complete and proven solution for NVH simulation, integrated with simulation technology for many other vehicle attributes. I would like to invite you to plan a visit to one of our sim centers to experience the VI Grade simulators and solutions firsthand. Contact your local VI Grade representative to schedule a visit or learn more about VI Grade solutions. You can also visit vigrade.com/NVH for more information on any of our solutions. As a final note, you are invited to join us for the Zero Prototype Summit this year on May 20th and 21st. Visit vigrade.com to register. Thank you very much for your attention.